Data mining. In this module, we're going to focus mainly on understanding how we could acquire data and how we integrate that data and actually derive value from that data. Now, the objectives in this module will be making up about 25% of the exam, so fairly significant. We're going to talk about data acquisition, manipulation, optimization, and profiling. As far as the lessons in this module, we're going to dive into data acquisition. We'll go into a demonstration on data acquisition and integration. We'll talk about APIs. We'll dive into a demonstration on Google Vision. Also talk about data profiling and cleansing. We'll dive into data collection methods. I'll talk about data outliers. We'll talk about ETL, ELT. We'll also talk about how we could optimize queries, and I'll go into a demonstration as well. We'll then talk about data manipulation techniques, and then we'll go through a summary review and some review questions. We have a lot to cover in this module, so let's proceed now to the next lesson. Understanding data acquisition. In this lesson, we want to understand the where, the how, and the why data is gathered. Now, when it comes to acquiring data, gathering data, bringing data into a data warehouse, to analyze it, to collect it, whatever the use case is, there's any number of different methods. Now, companies generally want to do this because of the fact that it gives them the ability to gather intelligence on what people want, what competitors may be doing. It also allows the company to grab resources, for example, in a form that's appropriate for whatever use case I have. So the various data collection methods that are available will likely vary based on the company or entity that you work for. When it comes to web scraping, this is where we use a pull approach where typically we're using a tool. It could be a tool like Scrappy or ParseHub. And this is typically going to be an extension we may add to our data applications, to our website, whatever that use case is, of course. And we're going to pull data from the website that we want to go to and collect information. If it's going to be Reddit, we may want to look at who's posting information on what are people asking about. These are things that we could do with web scraping. Now, public databases, these are databases that allow us to access information typically directly by querying data or actually downloading data sets and bringing them into our own collection as well. We could be using this on our own platform or on a cloud platform. For example, like with Google BigQuery, we can access a lot of these public data sets directly inside of the cloud data warehouse. APIs, so it could be cloud-based or third-party apps as well. Another way we could collect data is through surveys. So we could be sending out surveys through, like SurveyMonkey is probably one of the more popular ones, and collecting information and then assimilating that data into our research or into our whatever use case is that we have at the time. Sampling is an approach, not really a survey in the sense, but it's a way to sort of go out there and just get a feel for what people are doing. Then observation. We're not actively asking questions or gathering information. We're just seeing what people are doing. We may be just going to LinkedIn and just looking at what people are looking at. We may be going over to, let's say, the National Association of Realtors or even like Zillow, and we may use an API that integrates with these web services, and we may be just looking at just what people are doing. And this may give us an idea of what we may want to create an application around or improvements we may look at new market segments, whatever that use case is. The different data collection methods can really add value when we know what we're looking for and be able to, at the same time, apply the right tools and processes too. So with that said, let's move on to the next lesson. Data integration concepts. In this demonstration, I'm going to dive into the concepts around data integration and also follow up with some show and tell on how things can be set up, how things would work when we're using some of the common services such as Power BI, Amazon Redshift, or even Microsoft Excel. So let's proceed to the demonstration. The first thing I'd like to talk about is really focused on data integration. I'm over here at Power BI, the online cloud access for Power BI. Note there's also a desktop solution as well you could use. But before we get started with talking about integration with Power BI, I want to talk about some of the concepts for the Data Plus exam that we want to know. First, data integration is really a complex topic. It's really not a one-size-fits-all solution. Now, from a historical perspective, 20, 30 years ago, we didn't have a lot of tools to bring in data from different sources. When the cloud started coming out, the number of different solutions out there really exponentially just grew over and over and over. And also, too, at the same time, various sources of data multiplied and the amount of data multiplied as well. So when we consider data integration, this is really being able to combine different types and formats of data from different sources. Our company, for example, may need to collect data from a number of different sources. We're a sales-driven organization, so because of that, I may need to integrate LinkedIn information, Google Analytics, YouTube video information. I may also want to look at Facebook. And all of these data sources are going to either require APIs or some kind of extension that we could use to be able to actually bring in the data so that we could aggregate it and then view it, format it however we want. So it's important to realize that the data sets we're working with should allow us to actually make better decisions. Now, when it comes to Power BI, at the time of writing the course, there's probably well over 100 data connectors that are free, and then any number of paid ones as well. So if you want to integrate Google Sheets, you could do that. If you want to integrate LinkedIn or YouTube, you can do that as well. There's a ton of different tools out there that can help you with that. So as far as the data connectors, this is meant to extend Power BI to another application, such as, in this case, let's say YouTube. So I go over here and view monetization data. And again, it shows the number of views. It shows, for example, the number of likes, gives me visualizations, and I can also go in and customize this if I want. Now, when it comes to Power BI, there's a number of different data connectors we could use. There's over 100 plus free connectors available, and then as far as paid connectors, there's even more. But there's also different data integration tools we could use as well, APIs, so it really depends on what we're trying to do and how we're trying to do it, but where as well. Also, depending on the cost structure we have in place. So when it comes to data integration, Power BI is a great tool, especially if you want to bring in data and actually be able to visualize that data. When it comes to Amazon Redshift, this is a popular AWS web-based data warehouse. We can integrate data any number of ways, and it allows us to not only connect APIs, but we could also use what's called marketplace solutions. This would be similar to Power BI and using some of the connectors available. So we can do the same thing here. And remember, too, integration can be accomplished in any number of ways. So if we need to set up an ETL, we're going to approach that differently than basically setting up, for example, a data warehouse versus a data lake. So we have to look at integration from a number of different perspectives. Now, I go over here and discover products. And when I do that, I could type in, just as an example, Redshift. And I could look for Redshift connectors. Now, for example, let's say I want to use AWS Redshift and also integrate, for example, a very popular one would be Informatica, or actually one of the things that I'm seeing quite a bit of with a lot of the larger customers is we're using quite a bit of Kafka. So this would be a paid one that does have a free trial. And with your enterprise accounts, you'll likely run into that. And the last application I want to talk about is Excel. But before we do that, we need to talk about some concepts that we'll want to know for the Data Plus exam. Now, there's different types of processing that we could use. Now, we know that, for example, data can come in batches. It could be streaming as well. So we want to be aware that if we're using batch data, this is typically a one-time migration into the service. So, for example, I could go into Excel or Redshift or Power BI or BigQuery, whatever I'm using, and just bring in data one time. That's typically a batch data process we would set up. This could be done via an ETL. Then we could also use micro-batch processing. This is where we bring in smaller data sets that might be used more frequently. This could be, just as an example, IoT data, where we need to bring it in just little snippets at a time, where, for example, let's say it's a GPS. That GPS might be sending data out, and we want to bring it into a location. Let's say it's a logistical application that is being managed, and you have to report on it, provide reports. Well, that would be more micro-batch processing. Now, streaming data is something that we see quite a bit of nowadays, and this is where, for example, we may need to bring in information about how customers are interacting with our website. So we may want to bring in, for example, YouTube data, Google Analytics data, whatever that is. So just be aware that there's different types of processing. Lastly, let's say I want to use Facebook ads, and I want to be able to bring in the data and actually use it in Excel to derive value from that. I can go ahead and add in this specific add-in here. I have to accept the terms, but be aware that some of these, like this, may actually require a subscription to actually be able to use the functionality of it. So with that said, let's move on to the next lesson. What is an API? In this lesson, let's talk about application programming interfaces. Now, APIs are going to be something as a Data Plus professional you're likely going to run into. However, you're likely not going to be putting them together, assembling them, building them out, right? That's not going to be your role. But you'll likely need to have knowledge of what an API is. And the main reason is that APIs are going to likely be used in a lot of your applications that you're going to be using, from ETLs over to basically other data aggregation methods. Could even also be for your data lakes and data services that you may be running. So because of that, we want to make sure you understand what an API is, why it's important, what are the components, and the types. Okay, so first of all, an API is code that is going to allow two programs to actually communicate. Now, let's say, for example, we have our widget application that is on site. Well, we want it to communicate with AWS services over here. Let's say AWS Redshift. How do we actually tie them together so that I could have my widget application actually be able to send data over to Redshift so that I can then have my data team analyze those data points that we're uploading, let's say? Well, to do that, we would use an API. Now, there's two parts to an API. We have the specification and the interface. The specification is really going to be more about how we're going to communicate between each other. It's going to also entail like the encryption and items like that. And then the interface is really the software per se that's built to actually interact between the 2 points. Now, APIs are going to typically be either push or pull. So in other words, data may be sent automatically, but they can also go out and grab data. Now, the common specifications that you may run into could be REST, JSON, SOAP, gRPC, etc. Now, there's also open and proprietary APIs. Now, open would be Open API is a great example. Anything from like Apache, those are open APIs. Now, proprietary would be something you would get from Salesforce or from AWS in a lot of cases. Benefits. Why do companies want to use APIs? Well, the reality is that they want to be able to interface with different services, different applications. To do that, we would need an API. They also make things easier to integrate because of the fact that APIs are developed to provide really a limited scope of what they can do, and it's really a way to connect to a service. Another way I like to compare from a non-technical perspective in API is I compare it to a highway on-ramp. Now, you may have two highways that are going, one going east and west, one going north and south. Well, what do we have to basically bring the traffic from east to west to north to south? Well, we have what's called an interchange. Well, that interchange is very simply in the world of computer programs an API. That's really all it is. It's an on-ramp from one service to another service. Now, another thing, too, is APIs are notorious for really just making life easier for developers. The reality is that if you manage them really well, they can reduce security issues. They can also reduce development time. And in reality, APIs are great because of the main reason is that they're limited in scope. For example, get and put. The calls that are made are going to be limited. It's not like a full-blown software program that we could keep adding to. Now, API requests typically need the following to be able to communicate. We need an endpoint. In other words, we need to have a way for the API, let's say the sender to the receiver, to be able to communicate. To do that, we need an address. We use what's called a URL. So that would be, for example, if it's AWS, you're going to have the AWS address, and you're going to have all this additional code after that address, more or less, that'll point to that specific service and region and all that for connecting. Data formats. So we need to have a very specific data format that's used. For example, is it a put? Is it a get? What is the syntax allowed? Authentication methods. We also need to be able to communicate securely, and we're going to use a form of authentication. So how does an API call actually work? Well, first, the API has to be able to call an external server. So it needs to make a request. My widget application here to AWS. I need to be able to say, hello, I'm here. I want to connect to your service. It's a very simple way to look at it, but that's really what it's doing. So to do that, it needs to have the API URI to be able to process that request. That is the Universal Resource Indicator, or locator is another term we would use. We also would then need a valid request. If it's received, then the applications that are being called will then transmit that response back. So basically, we have a request from the sender, and then from the receiver is what? The response. Then the API sends the information back to the client. Really simple how they work from a high level and even a mid-level perspective. And in reality, again, even from a development perspective, really easy to deploy in most cases. Now, the common API protocols would be SOAP and REST. Now, for the exam, there's really two that I want you to understand. And so those are the ones that I'll be covering. From an objective perspective, that's what's really listed. Okay, now there's others, for example, like JSON, GraphQL, Apache Thrift. These are others you may run into in the world of data warehousing, ETLs, and all that fun stuff, right? So REST. REST is a set of architectural principles. So the service itself needs to have very specific characteristics. It's going to have very simple interfaces. And really the goal of using REST is that it uses low bandwidth. So it's driven by data, and it is very resource efficient is really the way to look at it. It is also supported by XML. Now, SOAP is the other one I want you to know. Now, SOAP is a protocol. This can trick people if you don't actually understand the main difference between these. So, for example, REST is an architectural principle. In other words, it's really a design approach that's used for web applications, for basically APIs that interface with them. Whereas SOAP is really more or less a protocol. So a protocol is what? More or less like HTML, or using, for example, UDP services, right? Those are going to be protocols. So be aware that this is going to use XML format to transfer data. So it's really using a protocol, whereas REST is really built on top of and is using very lightweight protocols to actually sort of bring the architecture together. So think about it as more of a design perspective with REST, and SOAP is really more of a singular protocol. That's about as simple as I can make it. Now, one thing I did want to point out here that I did actually run into on some of the practice questions was around WSDL. So WSDL is Web Services Definition Language. So what does SOAP use? It uses WSDL. So with that said, that's really the scope of APIs that we want to know for the Data Plus exam. Let's move on to the next lesson. In this lesson, let's get into a demonstration and talk about APIs, and I'll just walk through what is called Google Vision, and that's specifically an AI API with Google Cloud. Let's go to the demonstration. In this demonstration, I'd like to follow up on some of the concepts that we talked about in the API lesson. So we know an API is what? An application programming interface. This is really what we're going to use from a software communication perspective that is going to allow us to communicate with, let's say, a cloud service or something on-prem. And APIs, from an architecture perspective, are based on a client-server approach. So what I'd want to do is make a request, and I would expect to get what? A response. Now we know there's different ways APIs can work. We have SOAP, REST, for example, as two of the common ones. And because of that, we want to make sure when we go into the exam that we understand, of course, we have a client-server architecture. We have to make a request and then wait for what? A response. So hopefully that's clear. Now, when we consider a demonstration, I've got two different simple examples here. For the Data Plus exam, we do not need to know any of these applications I'm going to go through, but I just wanted to make sure that we have a concept down. So I'm over here at Vision AI. This is a Google Cloud service, and I go down here, and I could try the API. So what I'm going to do is I'm going to upload a file to the service, and it is going to look at this file after I select I'm not a robot, and it's going to analyze this photo. It's going to basically give some reasonable amount of probability here of, is this face? Is it sorrow? Is it happiness? Surprise? What is it? So you can see here that the confidence it has is about 91%. Now, objects is going to identify objects in the picture, so it can tell a laptop, a coffee cup, a tablet computer, for example, likeliness possibly, like over here. I don't really see a tablet computer, but it's picking up something that looks like it, at least from that perspective. It's looking at the keyboard, so you can see it's identified objects. Now, labels. It's picking up again that labels would be highlighted in the picture, and then text, if there's any text that is picked up as well, and then properties, and then what's called say search. Is it possible, for example, this photo has, for example, an AI generated fake? Is it modified like with Photoshop? Again, it's trying to pick up on things that might be obvious to the AI system. Now, I could also go down here and look at the JSON file. So JSON is going to be, in this case here, how we could communicate from our application to this application, allows us to copy this as well, and it gives us the request and then the response. Now, the other one I'm going to go through is called the Web Speech API. And so what I could do here is I could click on the microphone, and you can see here that as I am speaking, it is actually typing that information in. Now, we know that APIs are what? They're going to be making a request based on a client server. So what I'm doing now as the client, I'm actually actively making a request to the server in the back end of Google Cloud to basically translate my speech into text. So very straightforward. But for this exam, just be aware of what an API is, why it's important, understand that it's client-server architecture, and also, importantly, understand the different types of APIs that are out there. That APIs can be what? They could be SOAP APIs, they could be RPC APIs, they could be a REST API, or even a web-based API. Now, I didn't cover WebSockets very well, so that is a web-based API. So WebSocket API is going to use JSON. So, for example, the previous API I went through was actually a WebSocket-based API. So with that said, let's go ahead and move on to the next lesson. Data profiling and cleansing. In this lesson, we want to talk about the importance of proper data preparation. When it comes to preparing data, we first must profile our data and then cleanse that data. So because of these steps, we want to make sure that we first inventory what we have, that's data profiling, and then we want to cleanse data and remove any kind of efficiencies. Now, for the Data Plus exam, we definitely need to know these terms, and we want to make sure we understand the purpose. Now, when it comes to data profiling, simply put, it's a process of inspecting and analyzing data to determine its characteristics and quality. For example, is the data XML? Is it NoSQL? Is it SQL? Is it tables and rows? Or is it column-oriented? Right? These are things we want to understand. Is it stale data? Is it not stale data? These are things we need to look at in both the profiling and cleansing process. So when we consider data profiling, we want to look at it as a way we identify our data and create what's called an inventory of that data. We're able to identify that this type of data is located here, this type of data is located over there. So this data warehouse is going to be maintaining data that is archived for these specific types of data services. These are things we want to identify as part of the process. This takes time in larger organizations. It's really not a simple process. And it really is more difficult, of course, when you have multiple stakeholders involved as well. Now, data profiling really comes down to, again, inventory, as I stated, but also it enhances data efficiency. Now, I've highlighted those two words for a reason. When we prepare for the Data Plus exam, we want to make sure in our minds we understand the purpose of data profiling. It really comes down to creating an inventory to enhance our data efficiency. Now, data cleansing is a process of correcting and removing errors in our data. It could be removing, for example, redundancy, extra spaces, syntax, or format issues. When it comes to data profiling and cleansing, the benefits can be improved data consistency, data quality, and data security. This all creates what? Our efficiency. That's really the important points we want to know on this slide. There's three main types of data profiling. We have the structure discovery, content discovery, and relationship discovery. For example, if I wanted to go ahead and dive into my Redshift data warehouse and I want to look at the data sets that I have stored, I would then be looking at the structure. However, if I want to dive into that data warehouse deeper and look at the content, I would then be looking at the individual fields and what is contained in those fields. For example, is there privacy data? I need to also, of course, label that appropriately, and I should be able to identify that properly. So these are things we want to look at with content discovery. Relationship discovery. This is really understanding how all of these services tie in, what's available. For example, understanding that I can go ahead and use APIs with my Redshift warehouse to tie in other services. Maybe I want to tie in services from Salesforce, or I want to tie in other services, for example, with data discovery services. I want to use Splunk or whatever I want to tie in. So there's any number of different services that I may want to tie in to a data service. Doesn't have to be a data warehouse, of course. There's 4 main types of data profiling techniques that we may want to use to clean and validate data. Column profiling. This is the first step generally that we want to do when we look at our data services to match fields and data sets to really idealize what we have, and then hopefully determine in the next step what are the relationships to those fields and data sets. The next thing we want to look at is the cross tables. This is going to look at the types of tables and, importantly, the sizes. So when a table gets a little bit too large, that can create basically some opportunities around optimization and really help us determine, can we actually minimize that table space and ensure that we could run that data service as efficiently as possible. Now, when it comes to data rules, we want to also make sure that we have the proper data rules in place. And every organization will look at this differently, of course, but make sure that from a compliance perspective, from a governance perspective, security perspective, that you have identified the data rules and you're validating that they're actually in place. For example, some data rules could be as simple as enforcing that a field is actually going to need to be checked off, that needs to be selected, or it can be more complex as having very specific types of inputs accepted. So whatever those data rules are, we need to enforce them. What are some common examples of data cleansing? This could be removing duplicate records, could be correcting errors, could be standardizing data formats, removing outliers, could be removing sensitive data. For example, I was at an organization that was servicing mainly government-focused services at the time, and one of the challenges was privacy information. Over time, things change, the applications change, the fields need to change, and if we don't keep up with those changes, then we will have data that's out of scope, that is not cleansed, that is not profiled properly. So we need to go back and run through exercises to make sure that that data is actually sanitized and that there is no, for example, privacy data exposed where it shouldn't be. Data type validation. This is a really important part of data quality. So, for example, we may want to check that a field can only accept numeric values or only letters, or we can't actually allow wildcards, right? These are things we could do. Look at date fields. When it comes to data type validation checks, there's any number of different checks, right? It could be the data type. Is it going to be specific types of data such as CSV? Is it XML? What is really the format or the type? Is it going to be text? Is it a graphic, right? These are just some of the things we could be looking at. Could be the code that's used. Could be the range, the format, uniqueness, right? These are all things we can look at. Now, what are the 4 steps for data profiling? First is discovery. So we have to be able to go out there and discover what we have in our enterprise. The next thing is we want to go through profiling, right? We've discussed that quite a bit. Then we want to look at our standards. So the standards are what? We want to look at, do we have any compliance requirements we have to follow? We need to look at, for example, do we have all our forms and revisions of those forms? This is a big issue that comes up is over time, data can get stale, but data can also be out of standards because the form was updated Instead of having 4 fields, for example, in a drop-down box, we now have 5 or 10 or whatever it is. So these are things we have to look at. Then we want to start cleansing. We need to remove redundancies, fix the errors, right? So there's a lot of different things here with data profiling and cleansing. Now, for the Data Plus exam, I'm going to recommend you spend some time and review these topics in more detail because, again, this will be an area on the exam you'll likely run into more than a few times. Let's move on to the next lesson. Data collection methods. It's important that we understand the options when it comes to collecting data. Now, it is important, though, before we talk about that we do understand that we should be able to, as a data analyst, be able to select the right collection methods for the type of data that we're collecting. So if we know that the data is hosted on a cloud service, we're probably going to need an API, as an example. When it comes to collecting data, we need to realize that selecting the right method is just part of it, and that data we're collecting is going to be used in any number of different forms as we bring it into our enterprise. So we want to make sure that accurate data collection is something that we're actually aware of and that we're going to make it a point to ensure. Now, one thing to be aware of is that the data that we're going to be bringing into the organization is likely going to be used to make decisions in our organization. So it's so important, so critical that we plan this out appropriately. Now, before we collect the data, we want to be able to answer what the purpose is. So what exactly is the data going to be used for? Is it going to be used for small data lakes that we're going to bring data in and then run wrangling exercises against? Or is it going to be data that's going to be used to make business decisions that could be a result of the company making a lot of money or solving issues or researching a subject, whatever it is? So we want to know what exactly the purpose is. We want to know the type of data as well. Is it going to be structured data? Is it unstructured data? Is it PII data? What kind of data is it? We then need to know the source and the methods we need to use to bring the data into the enterprise. Now, we had briefly discussed some of the collection options that are available in a previous lesson. We now want to dive into these in more detail. So we want to be aware first that APIs are going to be used for web-based and cloud-based services. This is really important to really understand the scope of APIs in data collection. Now, when it comes to APIs, they're typically going to be either push or pull. In other words, the API may be used to send information from, let's say, a source to the target system. Now, that data could be as simple as stock ticker data. It could be data related to a medical science experiment or whatever that data is for. That data could be, of course, brought in via 2 different approaches. It could be pulled in from the organization itself through a script. It could then also be automated by an API and sent to us directly. So these are some of the things to think about. Now, there's different types of APIs. We have REST, SOAP, JSON, open, and proprietary. Now, also be aware, too, that some APIs will be push and some will be pull. So push meaning that it's going to push out to the target, and then if it's a pull type of solution, that means you, as the analyst, will likely need to find a way to grab data from a source and bring it into your enterprise. So we want to realize that there's different types of APIs. So when we consider other approaches, such as web scraping, this can be done via protocols, and there's a lot of great utilities out there for you to consider. So we have Selenium, Scrappy, Zeit, Beautiful Soup is widely used as well, And there's also a ton of Python libraries out there. So you as the analyst in whatever use case that you have need to look at what kind of data is it, and is it data that we could use, for example, a solution that is going to allow us to set up these data feeds correctly and pull in data as needed. Now, web services. There's also, again, a number of different services out there you could use. Typically, they're either going to be synchronous or asynchronous, meaning that synchronous, that data is continually updated, or asynchronous means that data is going to be updated only when there's major changes or it is actually set to change as well. Now, when it comes to data sites, there's a lot of different public data sites out there. Kaggle, Pew, also to a lot of federal government sites are open, so you could download data, for example, from Census, as just one example. Treasury has data, the Federal Reserve, you name it, right? So there's a lot of data that you can grab as a data analyst for whatever use case that you have. Now, machine data. This is data that's generated by typically servers such as a web server. This is going to be used in a lot of cases, not so much for you to run reports, but for you as an organization, a data analyst maybe in that organization, to understand issues that come up, to look at how things can be done better. This is a typical use case for machine data. And lastly, we look at surveys and sampling. There's a number of different ways we could approach a survey and sample. We could take data from a group of people in a small limited area like a neighborhood or zip code and run basically like a cluster sample. We could then look at performing random sampling where we look at different groups of people in different parts of the town to determine, are the incomes really disparate, or are they similar? Are they college educated, more in one area over another, right? There's a lot of things we could look at. So with that said, let's go ahead and move on to the next lesson. Data outliers. In this lesson, we want to understand how we could really dive into different variations in our data. Now, when it comes to data outliers, very simply put, this is a piece of data typically, or several pieces of data, that can be outside the normal distance from other values in a sample. So let's say I sample 100 people. Those 100 people are actually, let's say, high school students. Those high school students are all on a sports team. And all of those students, for example, may be playing basketball or football or whatever. So because of that, they're likely going to probably be a certain height, maybe a little bit taller, heavier, whatever. So we want to sample the height of these students. Well, if everyone is 6'2" on the basketball team, and then we have someone that's 4'2", that would be sort of a simple example of what could be an outlier. So is there really a person that's 4'2" on the basketball team? Or is it a data entry issue? Is it just some kind of other potential data sanitation issue that might have been missed, or whatever that scenario is with that data? So an outlier, simply put, is data that is outside of the normal distance. So if I have a bunch of basketball players that are 6'2", 6'4", 6 feet, maybe 5'9" at the slightest, that would be data that we would expect on a high school basketball team. But we wouldn't expect someone to be 4'2", let's say. Okay. Outliers can be caused by several factors, such as data entry issues, measurement errors, or something that's just out of the norm. So maybe there is someone on the team that is 4'2", right? Who knows? These are things we want to look into. Now, the goal of outliers can really be focused on helping us identify trends in our data. When it comes to displaying data outliers, there's any number of ways we could do this, and it will vary based on what we're trying to show. So if we want to look at the central tendency and the dispersion of our data, we could use the mean, the median, the standard deviation, and even quartiles as well. So in the graphic here, you can see we have an outlier, and you can see that we have the mean and median displayed, and you could show that, for example, it's pointing out the outlier that is really outside of what we would normally see. And looking at the other dots, you can see that pretty much they're all within the same blue line area, and that's what we should see. However, sometimes data may be outside of that specific sampling, and we want to look into it. Now, let's say we want to apply a formal test. What kind of a test could we actually apply to detect outliers? Well, it could be a z-score, it could be t-test, it could also be the Grubbs test as well. I'll talk about those here in a few minutes. Now, what about if we want to show the full range of our data? We could be using, for example, scatter plots, box plots, even violin plots as well. On the other hand, if we want to look at trends, for example, in the graphic there, we have a histogram, and you can see that again, that when we get to December, there's a drop in that data. That can be construed as an outlier, possibly, of whatever type of data it is. It could be, let's say, salary data. It could be volumes of sales, whatever that data may represent. Well, why did it drop so much in December? These are things we want to look into as a data analyst. When it comes to determining data outliers, we could use any number of approaches as we discussed, but let's talk about some of these that we mentioned. The first is the IQR. The IQR is known as the interquartile range. This is the 75th to the 25th percentile of the data. So, for example, any data that is between the 75th and the 25th is really the range that we would expect the data to be in. Anything outside of that is an outlier. So there's a commonly used rule that states that data points that are an outlier is typically 1.5 times what the IQR would be. So with that said, we want to look at those quartiles and determine, is that an outlier or not? Then we have the z-score. This is a measure in statistics that we could use that is going to look at a data point and determine whether or not that deviation is going to be 3 or less than -3. So again, it's an approach that is used more or less in a different manner than what IQR is, but it's a way to get a score of where that outlier is. When it comes to non-parametric statistics, this is a branch of statistics that does not make assumptions. And what that means is we're looking at really the population of what we're sampling. So we don't want to draw conclusions based on the population. So if we have ethnic groups, if we have income levels, we have ages, these are things we don't want to assume when we're actually looking at data. We want to really get the right data the first time. So we want to sample things properly. So as part of that, we want to make sure we use the right test. Is the distribution of that data correct? Is it ranked appropriately? So there's really two main tests. There's distribution-free and rank-based. When it comes to parametric statistics, this is a branch of statistics that makes assumptions about the distribution of the population from which the data is drawn. So if we know like certain zip codes may have higher ethnic levels or higher incomes, we can draw to the conclusion that the average age may be over 50. Again, these are going to be assumptions that are done statistically, not really from what I would call off the hip or from a data perspective without anything backing it up in a lot of cases. Now, what would be some of the tests we'd want to use? We want to use a t-test, the ANOVA test, correlation coefficient, or even regression analysis can also be useful. So for the Data Plus exam, there's a lot of terminology here. There's also different methods that you'll want to focus on if you're not familiar with them. So definitely take some time to make sure that you understand some of these in preparation for the exam. Let's move on. What is ETL and ELT? In this lesson, we want to talk about extraction, transformation, and loading data. When it comes to defining ELT, it's really the process of taking data from one source, which could be cloud databases, data warehouses, it could be on-prem services, SaaS solutions, whatever it is, and basically transforming it into a format that's suitable for loading into a data warehouse or other destination. This is used widely, of course, in data warehousing, data lakes, data analytics, and we commonly as well will use it in machine learning. The process itself is 3 steps: extract, transform, and load. Fairly straightforward. Now, when it comes to extract, load, and transform, this is really the opposite. When it comes to load and transform, we're basically loading the data into the destination before we transform it. So basically, we want to make sure that we take the data from the source, load it directly into the destination, and then transformation will occur after it is in that specific destination. So if we want to go into the data and remove any redundancy, clean it up, profile it, that's when we're going to do that, is after we load it. ELT is becoming somewhat more popular since it is more efficient generally than ETL. So how do they compare? So we have ETL and ELT. From the exam perspective, we definitely need to know the differences between the two. What is the use cases? We want to realize that if we're going to use ETL, we're going to generally be transforming the data on a staging area. Whereas with ELT, we're going to transform the data where? Typically on the destination. Now, the target use case is generally for, with ETL, really intensive transformations or for small data sets. Generally, ELT is great for larger data sets because one of the last things we want to do with larger data sets is to keep moving them around. Moving data is time and also can be money depending on where it's located. So if it's on a cloud service, moving data around is going to cost you money. Now, ETL is better for structured data, whereas ELT is better for unstructured data. The question about reliability, again, could be, is it manageable or less manageable? It's all about, again, really what you're using and how you're using it and your use case, I think. But in general, that's the accepted expectations. So when we compare ELT to ETL, you can see that, again, we're going to extract. It could be from a database, could be via CSV file, JSON, NoSQL. Bring it into load or transform depending on where we're at. Fairly straightforward. But again, for the data plus, we want to make sure we get the differences between the two. Loading data. So there's 2 types of loads when it comes to ETLs and ELTs. We're going to perform what's called a full load. That's where we bring in all of the data from the source. Now, what about if we don't need to have the full data load? Let's say we have 80% of the data and only 20% of the data sets change. Well, then we'd want to perform what's called a delta load. Now, generally, this delta load is going to be implemented via what's called a watermark. So we want to be aware of that for the exam as well. Another thing to really understand is the process of extracting data. So some of the tools we could use could be Demo Bench, could be Power BI, could be Redshift ETL. These are some of the tools that are out on the market that are available for actually bringing in data, transforming it, loading it There's a lot of different tools, Matillion, whatever you use in, Talon D, right? There's just so many tools out there. Now, importantly, this is very simple for a lot of people, but if you're new, I want to make sure you understand this. A CSV, what is a CSV? In the world of data analytics, CSVs are widely used. So you want to make sure that you understand that we're going to commonly use a CSV file to actually look for the data, to extract the data from the source. So if we're going in and we're basically pulling data, that CSV file is what's really used to be referenced from that data extraction exercise. So with that said, let's move on to the next lesson. Query optimization. In this lesson, let's talk about the importance and benefits of query optimization. So as a data professional, you're probably going to be running a good number of queries to really find out what exactly is the type of data available, what is the information you need for a report, where to find it, right? These are things that you want to really understand. So what exactly is a query? It's really a request for make-in against a database or a data warehouse to really retrieve information we need. So, for example, if we're using any number of SQL-based services, it could be Redshift, it could be MS SQL, it could be Oracle, we could be really looking at SQL optimization. So, for example, if we're using Redshift, though, and this is an important concept to be aware of, is that every service that you use, every application that you're using with SQL will have its own different approaches that you could really look at to optimize that service. So BigQuery will have similarities in how you could tune SQL for your queries, but there's also additional service-related query optimization capabilities to consider. So for example, in the case of Redshift, there's limitations that you want to be aware of. You can only have really a maximum of 15 queries at the same time in a cluster. You can make over 500 concurrent connections to a Redshift cluster. So we don't need to know what we can do in Redshift per se for the Data Plus exam, but I wanted to make sure if you're new to running queries that it's not just as simple as running a query in SQL, and how SQL is supported from a query perspective is going to be the same. So just be aware of that. Okay, so one of the things we can do is always put together what's called a query plan. This is going to be a plan that is going to specify what we're going to actually be looking for, and then look at as well what is the cost of running that query. So we could do this in a lot of the cloud services such as BigQuery or Redshift as an example, so you have an idea of what it's going to cost you to run a query. Now, why would it be important to care about the cost of a query? Well, in the cloud, you're paying for basically everything you do. So the amount of data you're pulling, the network bandwidth, the size of the table, right? These are things that add up from a cost perspective. API calls are actually as well going to be metered and charged for once you get over a certain limit. So these are things you want to be very cautious of. Okay, so when it comes to some of the fundamentals around optimizing queries, I generally like to really instruct people to think about what is the real business requirement here, and what data do we really need, and do we actually get that data from the right source? So we need to look at the business requirements to really line that up. So one of the things we should not be doing is to select everything. Don't use wildcards. If you can get the stakeholders to let you know exactly what they need, then this will help you identify the most efficient way to pull up that information in the query. So avoid wildcards. Also, too, select distinct. This is another gotcha in the sense of SQL. We have to be very cautious with using the syntax and be aware of select distinct. Inner join is another one as well. So be aware of using inner join in the right situations, but try not to, for example, use where in a manner that is going to be inefficient. So again, it's all about really understanding what you're really looking for and where it is and how you can retrieve it. We want to do things as efficiently as possible. Okay, use limits. So we want to use a limit as required. Now, when it comes to, for example, in this slide here, I've got an arrow. What this is doing is it's pointing out, for example, the very specific areas around, for example, how I'm creating a table, and I want to make sure that I create a table that is going to be supporting the event ID that I need, the venue ID, the category ID, the date ID, and then I'm going to have a very specific character number and a start time. So for example, I probably would want to also add to this, of course. I may want to look at compression. I probably want to also understand too, for example, on the cloud data warehouse, I need to also understand where the data is and where it will be stored. Is it going to be on S3, for example, or is it going to be local? These are things you want to look at a higher level, or deeper level, I should say, based on that specific service. Okay, so specifically now for the Data Plus. When it comes to query optimization, there's generally an accepted workflow to how we want to approach things. So for example, we want to parameterize as much as we can. We want to index. We want to also look at temporary tables. Look at also identifying subset of records that we need. So do we pull the full record or the subset, right? These are things we can do. Let's also look at, again, how the execution plan is put together. Now, when it comes to, for example, some of the things to look at is consider the fact that we have covered queries, uncovered queries. So, for example, is there an index or is there not an index? So an uncovered query does not have an index. Hint, you may want to remember that. Table scan is performed when there is no index file. So for us to really do any work, we need to understand where the tables are. So to do that, we need to perform a table scan. Indexing. So indexing is quite important in the world of data structures. So because of that, when we index, it does speed up retrievals, but it could also, in some cases, slow down performance, especially in the case of modifying data. Temporary tables. Now, this is where we have what is really a temp table or temporary space in our data service to basically buffer, is another way to look at it, data coming in and data going out. Lastly, we want to understand when we consider parameterizing our queries, why do we want to do that and how does it actually compare to a stored procedure? So stored procedures are query templates that we put together that are stored on a server to pass arguments. These are local generally, whereas a parameterized query is going to be a template that is actually built into the code. And it's really meant to pass arguments directly to the database. So we want to understand that there's two ways to approach parameterized queries. One is a stored procedure, and one is a parameterized query. What is the difference? One is local, one is actually built into the application code. So think of a stored procedure, for example, as more of a script we put together to help us with a specific query, whereas parameterized queries are really built into the application itself. So with that said, let's move on to the next lesson. data manipulation workflow and techniques. In this lesson, we want to focus on transforming and organizing our data. First, let's clarify what data manipulation really means. So manipulation itself is really what? The process of transforming and organizing data to make it useful for analysis. For example, we may want to bring our data into a data lake and then from there determine where we need to put it and how we want to actually start organizing that data and making that data, which is raw data, more useful. Now, generally, manipulation from a practice perspective follows a very specific process. We'll talk about that process here shortly. We're going to use techniques such as sorting, filtering, transforming, and again, we'll talk more about some of these coming up. Now, we want to typically use, from a query perspective, from running SQL, we want to use statements that are going to be focused, such as select, insert, update, delete. I like to refer to DML as being similar in the world of the files, for example, file structures, as CRUD, like create, read, update, delete. So that's pretty much what we're looking at here. So we can manipulate data any number of ways. Now, what are some of the tools we could use? We could be looking at Tableau. That's a very popular one. We could use Excel, depending on what we're doing, RapidMiner. We could also use Python and the libraries that will support that along with it. So there's a number of different tools out there that we could use. What is the workflow? So the workflow is really going to be summarized in 6 steps. Your organization may look at it a little differently, but in general, here is what we want to know for the Data Plus exam. First, we need to gather data. So what does that mean? I need to get data from the various sources and then basically place it where it needs to go. It could be a data lake, could be a data warehouse. Is it raw? Is it not, right? These are things we'll want to determine. We then need to clean and prepare the data. So I need to strip out the data I do not need. Then I want to go and look at manipulating the data the way I need it. I may want to join rows. I may want to move rows and columns around. Let's just say using Excel, simply put, right? Whatever I'm using, there's a number of different ways to manipulate that data. I want to analyze that data, make sure that that data is safe, secure, efficient, that we're able to run queries appropriately. We want to be able to visualize the data and then communicate the results. So that's typically the workflow at that high level. We do want to know this, again, for the exam. That's why I wanted to spend a minute or two extra on it to make sure we got it. All right, so the next thing we need to know for this exam is listed here. What are some of the techniques? So when it comes to filtering, so filtering simply put is what? I am basically specifying what I really want. So for example, if I go to Google, I can just type in a Google search and it'll give me pretty much everything. However, I could go up to the top of the browser and then select based on the date, the sources, does it have all the information or not, right? That's an example of filtering. Now in Excel, I could do the same thing. If I want only certain rows, I can do that, certain columns. If I'm looking for certain fields, I could sort that out as well. Now, sorting, of course, is a form of ordering. As an example, maybe I want to go ahead and look for anyone that hasn't paid their invoices. I can look for basically the field that would specify paid or unpaid, and that would be a way to order that. And then I could order it by how. So as part of like the ordering, it's going to typically be multiple things I want to order by. So it could be the last name, it could be the date that they're delinquent, it could be the amount that they're delinquent, right? Number of different things. Aggregating is an approach to summarizing the data. Simply put, I want to identify the data after I basically sort it out and filter and highlight what I'm really looking for. So for example, summarizing might be total owed might be $10,200. These invoices are delinquent by so many days, right? So depending on what I'm looking for, I could get as specific or unspecific as I so choose. If I just want a short summary, I could do that. Or if I want to be more specific about specific fields, I could do that as well. When it comes to joining, this is a common exercise where I want to invoke the join clause and say that I want to combine records from typically 2 or more tables in a database. And lastly, transformation. This is where I take a file or I take data and I change the format or structure. Simple example would be, let's say I have an Excel spreadsheet. I don't want it in Excel format, so what do? I want to convert it to a CSV, a comma separated value format. So again, with that said, we want to make sure we understand these data manipulation techniques and really be able to identify what exactly does sorting do, what is aggregation, what is joining. So with that said, let's go ahead and move on to the next lesson. Module summary. Let's go through a short review of what we covered in the module. We talked about APIs and we understand the importance and why we need to have an API. We need to be able to connect to disparate services so that we're able to grab data via any number of different approaches. So it could be through an export, it could be through a data load, whatever that process is, we may need to have an API to connect to that service. Now, we also learned about APIs as well in the sense that we need to have what's called a URL for that endpoint. This is really the target that we're going to connect the source to be able to connect to that, let's say, cloud service and be able to connect and authenticate and then be able to retrieve data. Remember, too, APIs are going to use very specific formats. They're going to use very limited syntaxes. So, for example, I'm going to get information. I'm going to pull information. I'm going to basically drop information into that specific source or target, whatever I'm setting up. Data profiling. Now, this is the process of inspecting and analyzing data. So, for example, if I have data I'm pulling in from a source, I want to make sure that that data meets the requirements. I may need to transform that data before I actually do anything with it. After I've looked at the data, I've profiled the data, I've effectively inventoried that data, I then want to clean that data. So cleaning that data is, as a simple example, looking at the data and removing any kind of extraneous information that's not needed, unwanted characters. It could be also changing the format slightly so that it can be imported and used effectively in that, let's say, cloud service or on-prem service, whatever that scenario is. There are 3 main types of data profiling. We have structured discovery, content discovery, and relationship discovery. We learned about data outliers, and if we have data that's outside of that determined sample area that we're looking for, then we need to consider that an outlier. So if I have a population that answered, let's say, the survey in a very specific range, and I have anything outside of that range, then that could be considered an outlier. Now, we also learned about mean, median, standard deviation, and quartiles. We definitely want to remember those terms for this exam. Now, we have parametric and non-parametric statistics. Now, non-parametric is really when we're not making assumptions, and this is really focused mainly on population. Parametric statistics is going to be focused on making assumptions based on the distribution of data within a population. Now we learned about ETL and ELT, so extraction, transformation, and loading. We learned as well about extraction, loading, and then transforming as well. So we know about those two very specific processes and how they work. We also learned about loading data. So we learned that a full load is going to be where we bring in data all at once and it's new. A delta load is going to be data that we bring in from a source, and that source may have some changes on it, and we only bring in the changes. That's called a delta load. And we learned about queries. That's when we're going to basically use SQL in most cases to query against a database or a data warehouse to grab the information we're looking for. Extracting data. This is where we're going to, again, like in the world of ETL, ELT, we're going to bring data from one source into a specific destination. To do that, we have to extract it from the source. So with that said, let's move on to the next lesson. Module review questions. Let's go ahead and test our knowledge. The first question is around ELT and ETL. So when we compare the processes of ETL to ELT, we want to understand what's similar and maybe what's different. So when it comes to the differences, we need to be able to select the differences. What would be the two differences? Feel free to pause and review this. With that said, the correct answer would be C and D. Remember that the processes are going to take raw data and transform them onto a secondary staging area, or they can move them back to the server, which is also known as a staging area. Now we also will take, for example, in ELT, we're going to take the raw data and transform that within the DW, which is the data warehouse. Now as far as the second question, which of the following would you define when setting up your source database to be synchronized with the target database to ensure that the changes are synchronized automatically? So basically there's a term that we want to remember, and that is called a watermark. The third one is around APIs. What are the two parts to an API that need to be defined? Now, sometimes there's 3, possibly 4, depending on the type of APIs. But again, we're not developers here for the Data Plus exam. We want to know these 2. That would be the specification and interface. Generally, the vendor and the product would not be something we'd have to define from our end. This is defined automatically when we connect to what is called the endpoint, the specification and the interface itself. So when we consider data types, which of the following data types is commonly generated by a computer process running application data processes, or it could be any other mechanism as well? That would be machine data. And for the last question, you are a database administrator and you create a pre-compiled query that is stored on the database server. Now the key here is to remember where it's stored and is it compiled or not. The correct answer would be a stored procedure. With that said, let's proceed on to the next module.